और एक go live representation वो enable auto start off करते हो go live okay
कहीं है Hello students, welcome to IMS GATE Academy. I hope you are doing great. Now students, I just want to tell you what is the importance of most expected concepts I have been telling you from the first day onwards. See students, you should have a basic concept clarification. Whenever you want to be success in GATE exam, you need some extra attention in some topics. There is no concept of most important. You have to go through every topics and you have to prepare your short notes and you have to prepare your own summary. But remember students, when you talk about the most expected concepts, there are some concepts in soil mechanics and foundation. If I am not wrong, if you will definitely see a question from properties of soil, shear strength, permeability, and also pile foundation and shallow foundation. And lot of questions are coming from earth pressure also. In these chapters, you need some extra attention on some peculiar topics. So remember my dear students, these most important concept series will brush up your basics and it will enhance your understanding on the important concepts. Now my dear students, as part of the today's concept, I would like to discuss you soil classification. As I told you in soil classification topic, the most important concept is plasticity chart. You should have an idea on plasticity chart before discussing the topic soil classification. So to understand the topic plasticity chart, you require some basics. So let us discuss those. My dear students, based on the particle size, soils are classified. Based on the particle size, soils are classified. Now my dear students, here if I take 2 micron, 75 micron, okay, 0.425 mm, and 1 micron is 10 power minus 3 mm, 2 mm, 4.75 mm, and 80 mm. Now see students, whatever the soil particles, if you assume more than 50% of the soil particles are passing through 2 micron, then we classify that soil as clay. Okay, if more than 50% is retained on 2 micron, we take it as silt. And remember my dear students, between 75 micron to 4.75 mm, it is sand. But my dear students, in sand, again we classify whether it is a fine sand, whether it is a medium sand, or whether it is a coarse sand. So this is fine sand here, 75 micron to 0.425, and 0.425 2 mm is medium sand, and 2 mm to 4.75 mm it is coarse sand. Now here 4.75 to 80 mm it will be gravel. Sir, I might be fast in this concept because I want to give time to the plasticity chart. To understand the plasticity chart, you required these things. Above 80 mm we called cobble, and remember my dear students, more than 300 mm we call it as boulder. More than 300 mm we call it as boulder. So this is how do you classify a soil, especially based on the particle size. So remember 2 micron, 75 micron, 4.75, 80 and 300. These will definitely help you. Out of these, I would like to discuss, these are very important, which I have circled. Because 2 micron to 75 micron silt, 75 micron to 4.75 it is sand, and 4.75 to 80 mm it is gravel. So my dear students, why do you want to classify the soil? Suppose if you are talk about fine grained soils, you have to understand these are helpful for filler material. If you talk about coarse grained soils, in transportation they can be used for subgrade. So to understand their purpose, or to, when you classify the soil, where to use and how to use can be understand. And by simply by looking into the sizes, or you perform sieve analysis, you could able to classify whether the soil is fine grained or close grained. Very good, my dear students. Now coming to the point, we have some organizations. One is SH2TO, and other organization is PRA, and other organization we have is HRB. Now my dear students, if you see the expansion of these names, ASH2O is the American Association State Highways Transport Officials. When I talk about PRA, Public Road Administration. When I talk about HRB, Highway Research Board. So here the most important thing is all these organizations are related to road or highway. So that is the reason, my dear students, they want to identify the soil. These organizations want to identify the soil which is suitable for payment. So their intention or their agenda is to identify the soil. They want to identify the soil which is suitable for, they want to identify the soil which is suitable for pavement design, or you can write which is suitable for road. Pavement is nothing but road or pavement design. So what they have done, see, all these organizations, they have given the names to the soil. Here they have given as A1, A2 up to A7. So my dear students, they classified the soil into 7 groups. Now you might have a doubt which is the best soil, whether A1 is the best soil or A7 is the best soil. Here, my dear students, you should understand that smaller the number, better is the soil for payment. My dear students, please understand this carefully. Smaller the number, better is the soil, you can remember. And remember, my dear students, out of A1 to A7, obviously A1 is the best soil and A7 is the poor soil. And here I would like to tell you, as black cotton soil is having more swelling and shrinkage, black cotton soils fall under which group, my dear students? They fall under a group called A7. So please understand this. Why black cotton soils fall under A7 is they have high swelling and high shrinkage, and they are not encouraged for the purpose of the pavement design. So these organizations, their intention is to identify the soil which is suitable for pavement. Hence they classified the soil into 7 groups, and they have identified that smaller is the number of the group, that is the better soil for pavement. Now one of your friend might ask you, suppose someone has got a group as A2 and the other friend of you also have got A2. Now both are A2 and A2. Then which is the best soil? You want to identify which is the best soil. In that perspective, in this perspective, my dear students, there comes a concept called group index. You might heard this group index. So what is the intention of group index? Can anyone tell me? What is the intention of group index, my dear students? Group index is used to indicate the quality of the soil within the same group. Means out of A2 and A2, which is the best soil? Means both are same group, but they will identify the soil which is the best in the same group. So let us write this, identify the soil, or you can say identify the best soil within its own group. Within its own group. Now my dear students, you have different soils A1, A2 up to A7. So here you are trying to identify the soil which is the best within the own group. Here on what basis actually this group index works? So remember my dear students, group index depends on some of the factors. So group index depends on the sum of factors. Can anyone tell me what are the sum of the factors is? The first factor is nothing but the how much percentage of soil is passing through 75 micron. Why they have taken 75 micron? It is simple, amma. If more soil, if more than 50% is passing through 75 micron, then we say it as fine grain. If more 50% is retained, then we call it as coarse grain. Here the percentage of soil passing through 75 micron. And here we have is liquid limit and another one is plastic limit. As I told you, what do you mean by liquid limit? Liquid limit and plastic limit are called as the Atterberg limits, or these are the water contents at which soil passes from one state to the other state. Or you can define, my dear students, liquid limit is the minimum water content at which soil has small shear resistance. When I talk about plastic limit, it is the minimum water content at which a soil can be rolled into 3 mm diameter without breaking or crumbling. So here you can simply say that liquid limit and plastic limits are the Atterberg limits. Now here we have a huge formula for group index that no need to remember that formula. But here I will tell you, my dear students, group index varies between 0 to 20. They can ask you group index in any of the state level exams or IAS prelims. These kind of questions can be asked. Group index varies between 0 to 20, and here also the same thing. Smaller the group index, better is the soil for payment. You can write smaller the group index, better is the soil. So my dear students, you can ask me what is the purpose of group index? The purpose of group index is simple. It is used to identify the quality of the soil within the same group. You can write here also identify the soil, or if you want to add, you can also add identify the quality of soil within the same group. And what factors group index depends upon? It depends upon the percentage of soil passing through 75 micron, liquid limit and plastic limit. And remember, the group index varies from 0 to 20. Smaller the group index, better is the soil for payment. I hope you are clear with the concept of group index. Now let me explain you how do you classify a system. My dear students, the first we call the soil classification system as unified soil classification system, which is followed in Europe as well as in the Europe and the American countries. So unified soil classification system or unified soil classification system is also known as, or it is also known as what, my dear students? Unified soil classification system is also known as airfield classification system. Here, my dear students, this system was discovered by Cascades. Already you know liquid limit is determined by the apparatus known as what? Cascades. Similarly, this classification system is also discovered by Cascades only. Now, my dear students, you can ask me on actually what factors the soil has been classified. Here on the basis of first one we have is grain size distribution. Grain size distribution is nothing but particle size distribution, my dear students. First one I would like to discuss is the grain size distribution. As I told you, based on the particle size, the soils has been classified. The second one we have is the plasticity characteristics like liquid limit, plastic limit, plasticity index. All these comes under the plasticity characteristics. Apart from this, we also have the factor called compressibility. We also have a factor called what, my dear students? Compressibility. So my dear students, I would like to tell you that based on these three factors, the soils has been classified. So remember my dear students, on what factors actually the soil has been classified is, one is the grain size distribution, second one is the plasticity characteristics, and third one is the compressibility. Now here you have the challenging part, that is simply you should remember that Indian Standard Soil Classification System, Indian Standard Soil Classification System, Indian Standard Soil Classification System is derived from Indian Standard Soil Classification System is derived from Unified Soil Classification System. It is derived from Unified Soil Classification System. So here the thing you have to understand that, sir, see, already Unified Soil Classification System is depending on these three factors. Now obviously Indian Standard Soil Classification is derived from this, means Indian Standard Soil Classification System also depends on these three factors only. Am I clear? As I told you, to classify a soil, whether it is a fine grain, coarse grain, or in addition to that you want to classify again in fine grain and coarse grain, you should have some basis. On what basis you are going to classify is, one is the grain size distribution, second one is the plasticity characteristics, and third one is the compressibility. So actually Indian Standard Soil Classification System is derived from this Unified Soil Classification System. Hence it depends upon the same factors only. Now here let me explain you one important thing. Here if I talk about soils, we have two types of soils. One is the coarse grain soils, my dear students, one is the coarse grain soil, and other one is the fine grain soils. So how do you classify a soil as a coarse grain? And now see students, if a percentage of soil retained is more than 50% is retained, if more than 50% is retained on 75 micron, then we call the soil as coarse grain. And what are the examples of coarse grain, my dear students? The examples of coarse grain is nothing but gravel and sand. The examples of coarse grain is what, my dear students? Gravel and sand. And how do you say that a soil is coarse grain? As you know, coarse grain means, Tushar dekha, hi. Tushar, hi. Any doubts in this? So here what I would like to tell you here is, when I talk about coarse grain, if more than 50% is retained, then it is called as coarse grain. Example is gravel and sand. Here when I talk about gravel and sand, obviously the more the size, obviously it will be coarse. But they have given the size 75 micron. Now similarly, how do you classify fine grain? How do you classify fine grain? So here when I talk about fine grain, a soil is said to be fine grain if more than 50% is passing through 75 micron. If more than 50% is passing, sir, passing is different, retained is different. So if more than 50% is passing through 75 micron, then we call that soil as fine grain. If more than 50% is retained, then we call the soil as coarse grain. Here, my dear students, when I talk about fine grain, we have two examples. One is the clay and the other one is silt. I hope you are clear now exactly how do you define clay, fine grain, and how do you classify coarse grain. And additional information, my dear students, clay is represented by C, silt is represented by, only this you have to remember, Amma, because people are habituated with their starting letter. So silt is represented by N, sand is represented by S, and gravel is represented by G, and organic soils are represented by O. So here I would like to tell you how the soil has been represented. So this is the challenging part you should always learn. So my dear students, whenever you talk about soil, first try to classify whether it is a coarse grain or whether it is a fine grain. After that, if it is a fine grain, whether it is a clay or silt, we will discuss. Whether it is gravel or sand, we will further classify. First initial task is how to classify whether it is a fine grain or coarse grain. When you talk about again like gravel and sand, you have to take 4.75 mm. If 4.75 mm you have taken, if more than 50% is retained on 4.75, then it is gravel. If more than 50% is passing on 4.75, then it is sand. Similarly, here you should talk about 2 micron. If more than 50% is passing through 2 micron, then clay. If more than 50% is retained, then it is silt. So here, my dear students, the intention of soil classification is you have to identify which soil is what based on the particle size. So my dear students, soil has been classified into, according to the Indian Standard Soil Classification, soil has been classified into 18 groups. Like you talk about well-graded sand, poorly graded sand, or silty sand, clayey sand, or clayey gravel, or silty gravel. Like that, soils has been classified into 18 groups. This can be a direct objective question. That is the reason I have told you. Now, my dear students, based on compressibility, actually what do you mean by compressibility, my dear students? If you remove air, then it is called compaction. If you remove water, then it is called consolidation. If you remove both air and water, then it is known as, compressibility. Now, my dear students, when I talk about compressibility, if the liquid limit is less than 35, you call that soil as low compressible. When liquid limit is less than 35, we call the soil as what? Low compressible. When the liquid limit is between 35 to 50, we call it as intermediate compressible. When liquid limit is 35 to 50, we call it as intermediate compressible. And here, my dear students, here I would like to tell you, when liquid limit is more than 50, we call it as highly compressible. When liquid limit is more than 50, we call it as highly compressible. So, based on the liquid limit, whether the soil is low compressible or intermediate compressible or highly compressible, we can decide. Now, my dear students, we have different types of soils like ML, MI and MH. Now, you can ask me, what is ML, MI and MH? ML is known as low compressible silt, MI is known as intermediate compressible silt, MH is known as highly compressible silt. Similarly, we have OL, OI and OH. Same thing here. Low compressible organic soil, intermediate compressible organic soil, highly compressible organic soil. Similarly, we have Cl, Ci, CH. Here also you can write low compressible clay, intermediate compressible clay and highly compressible clay. So actually, based on this, how do you classify these soils? We have a very important concept which I told you earlier. We have a concept called plasticity chart. Now, this is very important, my dear students. You should have an idea on how do you classify a plasticity chart. So let me explain you how do we see the plasticity chart. I'm just drawing the chart, Amma. So here how the plasticity chart looks is, the plasticity chart looks like this. Now see students, let me explain you. Here what I would like to tell you is, a plasticity chart is drawn between plasticity index, it is drawn between what and what? Plasticity index and liquid limit. First thing, whenever you are talking about some graph, you should know the what is x-axis and what is y-axis. X-axis is the known quantity, usually liquid limit, and y-axis is the IP, which is known as plasticity index. And remember, my dear students, this line is known as A line. This line is known as what, my dear students? Here we can call this as A line. Now, my dear students, here I would like to tell you what is the equation of A line. You should first understand what is the equation of A line. So, equation of A line is IP is equal to 0.73 into liquid limit minus 20. Okay, this is the equation of A line. So, here if you see the intercept here, this indicates 20, my dear students, because again I am writing here IP is equal to what, sir? Let me tell you. 1 second, student. Here we can write it as IP. You can also write here the equation of A line, IP is equal to 0.73 into liquid limit minus 20. This is the equation of A line. Now here see students, this 20 indicates the intercept here. This 20 indicates the intercept. Okay, here we call it as y-intercept and this is the x-intercept. You know this equation how it came? Usually from y is equal to mx plus c, and they have done for different soil samples and they have drawn a graph, and from that graph they have come up with this equation. IP is equal to 0.73 into WL minus 20. Now see students, here we have 35 and here we have is 50. Now my dear students, it is simple. Above A line we call it as clay. Above A line we represent as clay. Now see students, how do I write? Below 35 you told it is low compressible. Below 35 it is low compressible. 35 to 50 you told intermediate compressible, and more than 50 you told it as highly compressible. So the first and the important point you can write is above A line represents clay. And remember, my dear students, how do you say it is low compressible or high compressible is purely on the basis of liquid limit. Here I would like to tell you, if the liquid limit is less than 35, it is low compressible. 35 to 50 intermediate compressible, and more than 50 it is highly compressible. Now below A line it represents silt. So my dear students, you can write it as MH or OH. Here you can, sorry, 1 second students. Here you can write it as MI or OI. Here you have to write it as MH or OH. Here you have to write ML or OL. Why? Because see students, below A line it is obviously silt, but less than 35 low compressible, 35 to 50 intermediate, and more than 50 highly compressible. So the second statement I would like to tell you here is, below A line, you can underline, below A line it is silt or clay. You should write below A line it is silt or clay. So let us underline these two statements. Below A line it is silt or clay. So my dear students, When you talk about plasticity chart, it is very simple. It is a graph drawn between plasticity index and liquid limit. Above A line we call it as clay, and below the A line we call it as silt. And if it is less than 35 low compressible, 35 to 50 intermediate compressible, and more than 50 highly compressible. And there is another challenging part here. See students, if the plasticity index here is from 4 to 7, if the plasticity index is 4 to 7, you find both the natures of clay and silt. So my dear students, you should be very careful when the plasticity index is between 4 to 7. If the plasticity index is between 4 to 7, it has dual nature, that is, it has the combination of clay properties as well as silt properties. So here it can be around 10, 20 or something. I'm just writing the. So my dear students, when IP value is between 4 to 7, dual nature will be there. Dual nature here means it indicates both clay and silt. It indicates both clay as well as silt. So please go through this slide, and if you are seeing the recording session, my dear students, you just take the screenshot from these observations, like A is when above A represents clay, below A represents A line silt or clay, and the equation of A line IP is equal to 0.73 into WL minus 20, and 4 to 7 you have dual nature of clay and silt, and this is how the graph looks like. Is this clear, my dear students? Is this clear? Okay. Now see students, you might have a question. Sir, you are telling how to classify in clay and silt. You simply told above A line it is clay and below A line it is silt. But how do you distinguish the silt and organic soil? For that we have some practical test. So here your question will come, my dear students. How do you distinguish? How do you distinguish? How do you distinguish silt? How do you distinguish silt and organic soil? How do you distinguish silt and organic soil? For this, I will tell you, my dear students, how do you distinguish silt and organic soils? The first one we have is the color test. Okay, this is a practically color test, usually organic soils. Sir, all these are the tests you can write here. Tests for organic. If it is not organic, then obviously it will be silt. So let us stick to one thing. We are talking about the tests for organic. So how do you distinguish clay and silt and organic soils is, let us do the tests for organic soils, and if it is not organic, obviously it will be silt. Are you following, my dear students? So when I talk about color test, when I talk about the color test, the color will be dark grey, the color will be dark grey or brownish color. The color will be dark grey or brownish color. Similarly, the order, if you talk about the order will be pungent, or you can say very bad odor will be coming. The order will be bad odor will be coming, or bad smell will be coming. Now, my dear students, this test is very important. How do you identify the organic soil? This is very important. See here, my dear students, when the liquid limit, this is WL is nothing but liquid limit, the liquid limit after oven drying, if the liquid limit after oven drying, if the liquid limit after oven drying reduces by, if the liquid limit after oven drying reduces by more than, if the liquid limit after oven drying reduces by more than 25%, then it is treated as, organic, then it is treated as organic soil. Now I'll give you an example how we do this, student. Suppose here have an example. Suppose if the liquid limit initially is 100. Now see student, now the liquid limit after oven drying is, suppose you assume it as 60%. So how much percentage has been reduced? 40%. Did it reduce more than 25%? Yes. Initially it is 100, after oven drying it is 60. So it has reduced more than 25. Or simple words mein, suppose if you have 80, okay, and if the value is somewhere 55, okay, it might have reduced almost 44 percentile. So this also has reduced more than 40. In that case, it can be treated as organic. Suppose if you have 80 and it has been reduced to 65, so it might be reduced almost 19 percentile or 18.8 percentile. In that case, it is not an organic soil. It will be treated as clayey soil, silty soil. So my dear students, the example here is, if the liquid limit after oven drying is reduced by more than 25%, then we treat that soil as organic soil. Am I clear, my dear students? Very good, very good. Now here, let me explain you the important thing also. First, suppose there was a question given. Liquid limit is 40 percentile and plastic limit is 20 percentile. This can be a simple question how they can ask you. If liquid limit is 40 percentile, plastic limit is 20 percentile, they can ask you, how do you classify the soil? They can ask you, how do you classify the soil? So here there was a liquid limit, how much? 40 percentile, there was a liquid limit 20 percentile. And how do you classify this soil? Can anyone tell me? So whenever these kind of questions are asked, please see students, we should calculate two kinds of things here. Now, first thing is, using the equation of A line, using the equation, if you talk about the solution here, using the equation of A line, I would be like to understand what do you mean by plasticity index. Here plasticity index IP is nothing but what, my dear students? IP is equal to 0.73 into WL minus 20. I hope you are clear. So here IP is equal to 0.73 into liquid limit is 40 minus 20. That will be equal to 14.66. So here, my dear students, what is the value of IP? IP value is as simple as this. It is nothing but 14.66. So when I talk IP value is how much, sir? IP value is nothing but 14.66. Now here, if you see here, when I see the chart here, my dear students, simple understanding I am telling you. The A line is located somewhere at 14.66. Okay. Now you know the basic definition. IP can be found out using WL minus WP. IP is defined as the difference of liquid limit and plastic limit, and you got the value here is 40 minus 20. So this value will be equal to 20. This value is given as how much? It is given as 20. Now is 20 above the 14.66 or below 14.66? Sir, we have the A line located at 14.66, but the value which you have got from the standard is 20. So 20 is obviously above the A line. So 20 is above the A line. So my dear students, from the question, it is evident or clear that it is a clayey soil. So my dear students, it is a clayey soil. It is a which soil, sir? It is a clayey soil. And here we have two things. One is the low compressible soil and other one is the intermediate compressible soil, and other one we also have the highly compressible soil. Here liquid limit is 40 percentile. Here the liquid limit is between 35 to 50. So here the liquid limits falls in this range, that is 40. So the answer will be intermediate. So the final thing I would like to tell you here is, Ci. So the final answer will be what, sir? The final answer will be intermediate compressible clay. The final answer will be intermediate compressible clay. So it is as simple as that. So let us conclude with 3 points. How do you solve this problem? First thing is locate using the A line where the IP is. So the equation of A line is equal to IP is equal to 0.73 into liquid limit minus 20. Similarly, after finding that, find out the standard IP value using liquid limit minus plastic limit. Identify whether it is above A line or below A line. If it is above A line, it is clay, and if it is below A line, it is known as silt or organic soil. And another important information, my dear students, if you have to distinguish clay, silt or organic soil, then definitely in the problem, liquid limit after oven drying should be given. If it is not given, you cannot classify organic or silt. You can classify clay or silt, but you cannot classify whether it is a whether it is a silt or organic soil. I hope this problem will help you for a better understanding of the plasticity chart. Now see students, we have another concept. See, actually they might give you liquid limit, plastic limit and shrinkage limit. Sir, one kind of question asking, I am telling how the question can be asked. They can directly give you the liquid limit, plastic limit and shrinkage limit. But see, in some of the previous GATE questions, they are not giving directly. They are not giving directly. They will tell you at a water, so how the question can be asked? At a water content of 40 percentile and 28 percentile, the state of the soil is semi-solid. The state of the soil is what, sir? Semi-solid. At a water content of, please observe this students, at a water content of 40 percentile and 28 percentile, the state of the soil is semi-solid. And the soil behaves as a liquid. They will tell you like this. The soil behaves as a liquid when water content is more than 60 percentile. Sir, you are telling these are just assumed values. Sir, these are not standard values. To identify whether it is a liquid limit or whether it is a shrinkage limit, whether it is a plastic limit, I am giving you some example. Sir, here they have given, here they might give you liquid limit, plastic limit, shrinkage limit directly. But in some problems, they cannot give you liquid limit, plastic limit directly. In that case, they might give you that at a water content of 40 and 28 percentile, the soil is semi-solid. At a soil behaves as a liquid when the water content is more than 60. Then in that case, you should have an idea of the plasticity chart. So my dear students, the plasticity chart somewhere looks like this. Here see, if the water content is more than 60, this indicates 60 percentile. If it is more than 60, then they are telling it is as a liquid state. So it is evident 60 indicates WL and this state indicates plastic state, but this state indicates semi-solid state. Here see student, in the water content between range of 28 and 40, they are telling it is a semi-solid. So from this chart, you can write that WL is equal to 60, WP is equal to 40 and WS is equal to 28. So here my intention is simple, my dear students. Even though they have not given you the liquid limit, plastic limit, shrinkage limit directly, if you have an idea on the Atterberg limits, definitely you have high chances of solving the problem. Now let us see, when you classify the soil, whenever you talk about classifying the soil, whenever you are talking about classifying the soil, sir, see, if the percentage of soil or you can write percentage of finer. Sir, my dear students, don't worry what do you mean by percentage of finer. It is the alternative name of percentage of passing. So here, my dear students, if the percentage of finer is less than 5 percentile, then you talk whether the soil is well graded, or you talk whether the soil is poorly graded. Now simply one of the student might ask me, sir, why you are talking whether the soil is poorly graded or well graded? Why can't it be silty gravel? Why can't it be clay gravel? The logic is simple, amma. When you are telling percentage finer is nothing but what? Percentage of passing. So my dear students, if 95% are of same quality, suppose I have 98% of gravel and 2% of clay. Here I would like to tell you 98% indicates clay. So whether that clay is good or bad, you should. Gravel, suppose 98% is gravel and 2% is clay, you should talk about gravel, because more than 95% consists of same material or same properties. So in this case, my dear students, when finer is less than 5 percentile, you talk about whether well graded or poorly graded. And for these students, as I told you in the previous session also, for any soil to be well graded, both conditions of CU and CC should be satisfied. What is CU? Coefficient of uniformity, which talks about particle size range. CC, which talks about the shape of the curve, that is coefficient of curvature. Now, my dear students, if I have talked about SW, then this is called as well graded sand. Here I talk about well graded sand. Okay. So for well graded sand, Cu should be greater than 6. Similarly, if I talk about GW, well graded gravel, here this Cu should be greater than 4. So there are some conditions for Cu when the soil is said to be well graded or when the soil is said to be poorly graded. So this is one of that example. Now see students, you might have asked me how to represent the soil also. If suppose there is a soil called silty sand. Sir, see students, actually you should be able to, you should be aware of this also. When you move towards the right, the composition will be more. So for your understanding, I am telling you, there is no science. Here if they tell you silty sand means, remember that sand composition in by weight is greater than the silt composition. If they tell you silty sand means sand composition will be more than silty silt. So as the sand, and remember when you are giving the naming conventions, definitely first priority is for composition. Whichever is higher, that will be given. So here silty sand indicates sand is the highest composition. So sand and silt is represented by M. So it is taken as SM. Similarly, if you talk about poorly graded gravel, gravel. Now, first of all, when I talk about poorly graded gravel, first of all, what is the type of the soil here? The type of the soil is nothing but gravel. So here gravel will be given, and what is the quality of the soil? It is poorly graded. And suppose if they give you, this is also asked in one of the exam, okay, they might give you clayey silty sand. Okay, clayey silty sand. What does this clayey silty sand indicates is, anyone can you answer me? What does clayey silty sand here? Clayey silty sand indicates that sand composition is, clayey silty sand indicates sand composition is more than silt, and silt composition is more than clay. So these always you should have an idea. Okay, my dear students, just how to name the soil also this slide will help you. Now see students, when percentage of fines are also known as what, my dear students? Percentage finer or percentage passing. When percentage of fines are more than 12 percentile, okay, when percentage of fines are more than 12 percentile, here you should talk whether it is a silty gravel, okay, because I'll tell you, wait, or you can talk about clay gravel, I'll tell you, or you can say silty sand, or you can also write silty sand, or you can write clay sand. See students, silty sand, or here silty gravel is represented by GM, clay sand is clay gravel is represented by GC. Same here, silty sand ESM, and here you can also write SC. As I told you, as you move towards the right, the composition will be more. Now see students, why you should be writing it has silt or clay. Here it is simple, amma. If you take some 100 grams of soil, in that they are telling more than 12% it contains fines. Fines means nothing but fine grain. Suppose there can be 75% of gravel or 25% of silt. So in that case, what is the answer will be? You can write it as clay 20. So first one, silty gravel. So here when fines are more than 12 percentile, if the fines are less than 5 percentile, we will never talk about silt or clay. If it is more than 12 percentile, we talk about whether it is a silt or clay, because it has substantial amount of silt or clay. And another important thing is, here this is important, when fines are between 5% and 12%, when the fines are between 5% and 12%, when the fines are between 5% and 12%, or IP value between 4 to 7, we will have dual nature of the soil. We will have dual nature, that is nothing but, I will give you some example like silty sand, clay gravel, something we denote something like this, SMSC, silty clay sand. Okay. So remember, my dear students, whenever the fines are between 5 and 12, and when the fines are greater than 12, you talk about silt or clay. Between 5 to 12, you talk both silt and clay. That is the reason it has some dual nature. Now, my dear students, now let us summarize. Let us summarize what we have learnt in the class. Now see students, the first thing is soil is classified into 7 groups. Okay. And here you can write A1 is the best soil. A1 is the best. Under A7 there will be a black cotton soil. And you know, group index indicates the quality of the soil, within one group. You can write simple words I am writing. And here also it varies from 0 to 20. 0 will be the best soil and 20 will be the bad soil. And remember, my dear students, Unified Soil Classification System is based on grain size, next particle plasticity characteristics like liquid limit and all, and also it depends upon compressibility. And here, my dear students, Indian Standard Soil Classification System, derived from unified soil, and it also classified the soil into 18 groups. And here when liquid limit is less than 35, when the liquid limit is less than 35, we call it as low compressible. 35 to 50, we call it as intermediate compressible, and more than 50, we call it as highly compressible. And remember, my dear students, the most important equation, the equation of A line. The equation of A line, which is very important. The equation of A line, if you are writing any competitive exams, this is very important. The equation of A line, IP is equal to 0.73 into liquid limit minus 20. I hope with this video you would be able to classify the soil. You will have an idea about the plasticity chart, how the naming conventions have been given to the soils. And my dear students, it was really nice interacting with you. If you are really happy with the sessions, please share to your friends, and it would be very fruitful for the students who are already started their GATE preparation and they want to enhance their skills in a particular topic. And remember, my dear students, we are proudly saying that IMS GATE Academy is conducting both offline GATE coaching as well as online GATE coaching. We are offering the offline GATE coaching at Jayanagar Center and as well as at Vijayawada. We are offering the online GATE coaching, both it records both recorded sessions, and we are also creating live sessions also. And students, here at IMS GATE Academy, we are proudly say that we have an excellent program where we have seen results from the student success point of view, where we call it as one-to-one mentorship, where we will be mentoring the student in every month, and we will be identifying the weak areas and how these weak areas can be converted into their strength. Apart from this, we have excellent doubt solving portal where the doubts can be posted in the portal and that doubts can be answered in 24 hours of time. And remember, my dear students, especially in civil engineering, we have a beautiful team, and me with my colleague Pratik Mishra. Pratik Mishra will be handling environmental engineering. He has also started the most expected concepts, and we are into every branch. So students, if you are really passionate and if you want to look for a civil engineering, the most important concepts, as I have been telling in all the respective videos, if you are talking about civil engineering, we have environmental, geotechnical and transportation. If you can read these three subjects along with your engineering, mathematics and aptitude, which you might have a more means where you will more comfortable with engineering and maths and aptitude, which you will be learning from your childhood days. So students, with these 5 subjects, if you can concentrate in the month of September, October and November, definitely there can be a high chances of getting a rank below 1000 or 1500. So it is a very nice opportunity for me to interact with you. Thank you. I hope this session will help you regarding the soil classification.